Hey there everyone, welcome to another Minecraft Redstone video here on the channel, and this whole video is dedicated to comparators and how they actually work, because I actually believe that comparators are some of the most misunderstood redstone components in the game. I think a lot of players know of them and know they exist, but they don't quite fully appreciate or understand how they technically work in the game. So the aim of this video is to make sure you're crystal clear on what comparators can actually do. There are four main things I'm going to show you in this video. And first off, before we get into the nitty-gritty details, we have the comparator right here. Now, the first thing that you should be aware of is that a comparator, when you place it down, has directionality to it. So that's pretty similar, to redstone repeaters. So as you can see, these are both facing in a particular direction. And essentially with a comparator, you have output going out of the front like so, but you can also have input on three areas of it. So in the terms of the comparator, you can have left, right, and back input into the component itself. So bear that in mind because that's going to become important later on in the video. But the first thing we actually have to display here is that also comparators have two modes to them. They have the comparison mode and the subtraction mode. So in default mode, it's in comparison mode, but if you interact with the comparator, this redstone bulb will activate and that will be in subtraction mode. So make sure you're aware of that as well. So the first feature when it comes to redstone comparators is that if there is only redstone input into the back of a comparator, like in this example right here, comparators actually work differently to redstone repeaters. Redstone repeaters actually repeat the signal strength at its highest potential. So if you end up having input going into a redstone repeater and it's very weak, the redstone repeater will then relay or repeat the signal, but it will strengthen it. It will end up being full power or full signal strength after the redstone repeater. But comparators are actually different. A comparator actually maintains the signal strength that goes into it. Okay, so in this example, we have full signal strength into the comparator. So this is signal strength 15. And because of that, this will then output a signal strength of 15. So this output will go on for 15 blocks, as you can see here. Now, this is what happens here, where if I move this torch back one block, so now signal strength 14 is going into the comparator, you will notice that the actual, signal is actually dropped down by one block because of that alteration. So make sure you're actually aware of that when it comes to comparators. The second thing I want to go through with comparators is their utility, functionality with container and other kinds of blocks. Comparators can actually work with many different blocks in the game, but the most simple case is when it works with a container, like a chest. The idea is that the comparator actually analyzes the contents or the state of the block. So in this case, we have a comparator that's analyzing the chest contents of this particular block right here, this chest. Now, what ends up happening is, depending on how many items are in the chest, it will output a certain signal strength from the comparator. So at the moment, it's signal strength 3 using 4 stacks of items. But if I take a stack out, you'll notice that it now has reduced to signal strength 2. So as you can see, as you change the contents of the container, it will change the output of the comparator. Now, this is not the only case that this can work with. There are too many different like comparisons and checks that comparators can do that I can actually show in this video, but I will leave a wiki page for the comparator in the description, and that should have a full list of everything that a comparator can actually analyze. But just to give you some different things that it can actually do. It can analyze item frames, so the rotation of an item inside an item frame. It can also do, jukeboxes, or it can do droppers, dispensers, lots of different things. Alright everyone, we're now going to go into feature 3 and 4 that I'm going to go through in this video. This is the more technical side to comparators. And the first one we're going to go through is what happens when we're in comparison mode. So that's in the default state of comparators. So when a comparator is in comparison mode, this is the formula that it actually uses, okay? So the output of the comparator equals the following. It takes the back signal strength, it then times it by an AND logical comparison. What it does is it takes the left signal strength and it checks if it's less than or equal to the back signal. And it then checks the right signal and if it's less than or equal to the back signal. Now, if these both are true, this AND comparison will return 1. If both of them are not, it will return 0. So there are two cases which will actually happen in this case. You'll either get the back signal strength times 1 or times 0. Now, obviously, if it's times 0, the comparator will not be powered and will not actually give any output. But if it's 1, then whatever is coming through the back will be allowed through the comparator. That's essentially what comparison mode does. So we have this case right here where we have the left signal strength, the right signal strength, and then here we have the back signal strength, okay? And as you can see here, we have this following sort of configuration, okay? So the left and the right signal strength are 13, as you can see from this example, and the back signal strength is 15. So if we are to do the formula, we then check if the left and the right is less than or equal to the back. And they indeed are, because we've got 13 and 13, which is less than or equal to 15. Now, because of that, this power level 15 is allowed through the comparator, okay? So as you can see, you can do that sort of logical step, and if you do that formula for every time you use the comparator, you should be able to figure out what the output of the comparator will be. Okay, so we're now going to go on to the fourth one. Now, this is the most complex. This is subtraction mode. So we're going to be looking at subtraction mode of the comparator. Now, when this actually happens, this is the formula that the comparator uses. Now, the reason why it's called subtraction mode is because there is subtraction done in the formula, which I'm going to get to in just a moment here. Now, you may notice that there's this max function in the formula. That's a pretty simple mathematical operation. All it does is it takes two terms that's been given to it, and it literally picks the bigger of the two. If both are the same value, obviously it doesn't matter which it picks, but make sure you are aware that's what is being used in this formula. So in this case, the output equals max, and then one term, and then 0. The first term is the back signal strength minus the max of the left and right signal strength, okay? So we take the back signal strength and then we minus the left or right signal strength from it. We then take that result and then put it into a max function with 0. So essentially what ends up happening here is the first term of the max function can be positive or a negative number. If it's positive, then the comparator itself will provide output of some kind. Obviously, if it's 0, it won't do anything. And if the first term of the max function is negative, because we're using the enclosed, the overall max function, it will choose 0 as the output because obviously 0 is bigger than a negative number. So it's a little bit more complicated in this case, but hopefully with how I've presented it here, you can kind of understand what's going on, okay? So we're now going to do a sort of example here. So I've put it into subtraction mode and we're going to go through this example, which is very similar to the one we just did, but the actual output is different. So what we end up doing here is we do the following, okay? So we take this example and what we do is we calculate the first term of the max function. So that's going to be the back signal minus the max of the left and right. So we're going to take 15 minus 13. Now left and right are both 13, so I can pick whichever one I want. So that is 15 minus 13, which is equal to 2. Now we then take the max of 2 and 0, which is signal strength of 2. And as you can see, this comparator is outputting 2. Okay. Now, if you get a setup like this, you will be able to play around with it and figure out what changes what. But if you apply that same formula that I just went through, you should be able to also, in this case, in subtraction mode, actually be able to calculate what the output of the comparator will be. Alright everyone, that's about it for this tutorial. Hopefully it wasn't too long and cumbersome, and hopefully it was helpful to some of you out there that wanted to understand what comparators actually do and essentially what their features are and what their implementation is like in Minecraft. But if you did find this video useful and you liked the video, then a like and subscribe on the video would be very much appreciated, and make sure you hit the notification bell so you stay notified of any future videos here on the channel. And if you want to follow my Twitter, it's on screen or in the description. But have fun redstoning as always, and hopefully you can incorporate these comparators into your builds now that you understand them a little bit more thoroughly. But thank you for watching everyone. Have a nice time, and I will see you in the next video.